So with this type of problem, I thought people would get confused on it, but it works out really, really nicely. Oh, I don't remember what example we're on. Whatever, I'm just going to do example 1 again. So, I mix up the colors, I don't know why. If I had something like this, 4n to the 12th minus 32n to the 7th plus 48n squared. If I had this, again, my first step is always just to divide by what's in common. So I'm going to divide here. It looks like I divide by 4n squared because all the numbers are divisible by 4, and the largest variable that I can take out is the n squared. It's the smallest variable that's there. So whatever I divide by, I write on the outside. And then I have I subtract the exponents because I'm dividing, so that's just n to the 10th minus, it looks like 8n to the 5th plus 48, is that 12? I think it's 12. And I wrote this down, and in class people just said, like, wait a minute, can you do the x factoring? Can you use the x? And I was like, that's you're a genius. You're a genius. Have an A, and I just then they don't have to do any work for that's a lie. But yeah, you can do the x factoring for this. You just have to change one little thing, and I'll show you. Because look, this is an exponent of 10 and an exponent of 5. Normally, for x factoring, we would have had something like this. You don't have to write this down. It would just be n squared minus 8n plus 12, right? And here we could use the shortcut. So here we can also use the shortcut. Here's the thing. And I'm going to try and relate it to that, but we'll see. So in the top, I think I would have 12, right? Because it's 1 times 12. And then negative 8 in the bottom, that's the b term. And that would be just negative 6 and negative 2. Yeah? Yeah. So then, what do I have? I have 4n squared. And I can use my little shortcut, n minus 6, n minus 2. However, if I were to multiply this out, and I encourage you to try it, I would get this. And that's not what I want. What do I want? I want n to the 10th. So I'm thinking like, okay, well, if I did n times n, that would give me the n squared. So here, if I did n to the, and this is the new thing, n to the 5th times n to the 5th. That will give me n to the 10th. And I encourage you to multiply this out, and it actually will work. N to the 5th times n to the 5th is n to the 10th. Sweet. And I'm checking it right now. N to the 5th times negative 2 would be negative 2 n to the 5th. Great. Negative 6 times that would be negative 6 n to the 5th. Great. This times that would be positive 12 plus 12. And then I could combine like terms. Remember, I already had an n to the 10th there. Combine like terms has to be, I'm just checking it. N to the 5th, that's what I wanted, plus 12, right? That's exactly what I wanted. So, really, it is the same stuff that we've been doing, except for we have to change the exponent because the exponents are different over here. So we have to change these exponents. But the rest is all the same. There's nothing new. So that's the answer. Just be careful with the exponents. If you don't have just a 2 and a 1 there, then it's different. Okay, sweet. Adios.